Assalamualaikum and very good evening, Dr. Shaifuddin. Today we are from Group 8. We will be presenting our project on the Aquaponic system, which we have designed on Tinkercad by using Arduino. Okay, so hi, my name is Adam Muzais bin Anzira and I am responsible for the sensor module setup. So basically what I am tasked to do is to deal with two sensors, which are temperature sensor, the MP36, and also the pH sensor, which at this case we are using the potentiometer due to the reason of Tinkercad not having a pH sensor in it. So by using a potentiometer, we can mimic it as a pH sensor where we can alter the values. I have connected the temperature sensor into pin A1 and also the pH sensor, which is the potentiometer, into pin A0. So we'll move on into the thresholds in the systems that I've created for each sensor. So number one is the pH sensor. So where I have set where the pH minimum would be 6 and the maximum would be 8. So anything below than 6 will be acidic, and anything more than 8 will be very alkaline. So anything in between will be the right temperature, will be the right pH value for the fishes to live in. So the next one is the temperature sensor. Anything in between 24 and 27 would be the ideal temperature for the fish to live in. So next we'll move on into the functions of each sensors. So we'll go into temperature sensor, which is the TMP36. It is an analog pin where I've connected it to A1 and it converts voltages to Celsius. It works by it gets the sensor's voltage and then it subtracts by 0.5 and then it multiplies by 100 where we can get the final temperature in Celsius. So the next one would be the pH sensor, where the potentiometer is. So how the potentiometer works is that it reads analog value of 0 to 1023. So it maps and converts it into a volt range of between 5.5 and 8.5. The reason why I chose that is because anything, as I've said earlier, anything in between 6 and 8 is the ideal temperature. So anything below that, anything above than that will be a warning to the user. So anything below or above, the LED light will turn on red. So the reason why we're doing this is to check whether the pH value is safe for the fishes.
Hello, I am Iskandar. My part of the Smart Aquaponic project focuses on sensing and controlling the environmental conditions. So, for the pH monitoring, we use a potentiometer as a substitute for the actual pH sensor, since real pH probes are not available in Tinkercad. The reading is done using the code this one. The potentiometer gives a value from 0 to 1023, but I mapped it to a realistic range of pH 5.5 to 8.5. This helps me to simulate the acidity and alkalinity changes accurately for demo purposes. And also for the temperature system, we use the TMP36 analog temperature sensor. The reading function is, so the TMP36 outputs a voltage proportional to temperature. The equation converts voltage into degrees Celsius, and the system checks if temperature is outside the safe temperature for water, which is 24 to 27 degrees Celsius, which is ideal for aquaponics. And if the temperature goes beyond this range, the buzzer will activate. Then the LCD also will warn the user. So next, for water level detection ultrasonic sensor, we use the HCSR04 ultrasonic sensor. This one. The sensor measures distance to the water surface. Next, the solenoid valve control, which is the water refill system. When the system detects low water, it automatically activates the solenoid valve. In our simulation, the solenoid is replaced by a DC motor through a relay, which means if the water level is low, then the solenoid will on, and if it's normal, the solenoid will off. This simulates an automatic top-up system commonly used in real aquaponics. So for pump control, the pump runs the water circulation loop, which is essential in aquaponics. In our project, we represent it using another DC motor. We keep the pump running continuously because fish tank water must circulate to the grow bed, and plants rely on nutrient-rich water, and also to make sure the oxygen levels remain stable. Lastly, I also handled the alarm system that alerts the user if any readings go abnormal. So using this code, when the pH level outside of the range, which is 6.5 to 7.5, the LED will turn on, and if the temperature will outside the range, the buzzer will beep. This provides instant feedback without needing to check the LCD.
Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aikan Azri, and my responsibility in this project is on the feeder and the timing module, which will control both automatic and manual feeding system in our aquaponic project. For the feeding schedule, as you can see here, we actually want to use the RTC module. However, since TickleCat does not support an RTC module, I change it into a millisecond based timing system, as you can see here. This allows the feeding cycle to run in the background without the needing of stopping the rest of the program. So we actually have two mode. One is a demo mode and a normal mode. The demo mode we create here just for this presentation, and we will trigger the feeding cycle every 30 seconds. While in a normal mode, the feeding will happen every 8 hours as a normal aquaponic process practice. So next, we'll go to the schedule feeding system here, feeding code. This automatic feeding code will check how much time has passed from the previous feeding cycle. Yeah. With this code, it ensures that the feeding is consistent and it's actually non-blocking system. For the feeding mechanism itself, we can see here the feeder part. I program a servo motor to rotate from 0 degrees to 90 degrees to simulate dispensing food, and then it will return to a 0 degree after the time has passed, the duration has passed. The LCD also will show a feeding, which indicate a feeding process, so that the user know the feeding cycle is actually happened. Next, I also implement a manual feeding button with a debounce logic. Yeah, as you can see here. So when you press it, the feeder will automatically activate, and the feeding timer will reset to avoid double feeding. Finally, as you can see, based on this whole coding process, my module integrates smoothly with the rest of the system, which means that even though the feeding cycles begin, the sensor will continuously update, the alarm will still function, and the LCD will return to the live reading after the feeding cycle ended. Using this non-blocking timing approach, it ensures that all modules in the system run together without the needing of freezing the system. So that's all from me. I will pass to the next presenter. Thank you.
Hello, my name is Ahmad Sharul, and my task in this project is display and data logging setup. Basically, I'm responsible for how the system shows information to the user and how all important readings are recorded for monitoring. My part ensures that the temperature, pH value, and water level are clearly displayed on the LCD and also logged automatically at fixed time intervals using the serial monitor. This allows our aquaponics system to be easier to understand, easier to troubleshoot, and more reliable. I will now explain three areas: the logging interval, the LCD display, and the serial logging that I did. from the coding in Tinkercad. I'm gonna look here because my monitor is here. So first of all, what I did is the logging interval. So we're using millis because we're doing the interval set in milliseconds, and I set the logging interval is at 5,000 UL and 6,000 UL. Since we are running in demo mode, log interval becomes 5,000 milliseconds, which means that the system logs the data every 5 seconds. Using millis instead of delay is important because it allows the Arduino to continue updating the LCD, checking pH, controlling delays, and monitoring the water level without pausing the entire program. So next, what I did is the LCD display setup, which is this part. This is just for the starting of the simulation where the LCD lights up and says Smart Aquaponic. What I did next is for the output from every part of the simulation. So first of all is the LCD display is for showing real-time sensor values in the code. What I did was on the top left is going to display the pH value, and reading the input is going to show at the LCD from pH is coming from the potentiometer here. And beside the pH value is going to print out the temperature. The temperature is coming from the temperature sensor here, which is somewhere around here. Below the pH value, we have the water level. Water level is on the second row of the LCD. And what I did was I also used two if-else loops. The first one, if the water level is insufficient or exceeding, it's going to print NA at the LCD. The other loop is for explaining if the pH level, the potentiometer here, and the temperature sensor and the water level sensor here, the ultrasonic distance sensor, which we use for indicating the water level. If it's exceeding the amount that we set, it's gonna print out these messages. That are the conditions for this loop, and the exceeding condition is everything is okay. It's gonna print okay. And the last thing I did is the serial logging, which is down here. I just use an if loop. So serial logging prints structured data to the serial monitor, which is down here. I didn't run it, but it's gonna come up here. In the code, our serial logging looks like this. It's gonna print log somewhere around here, and then it's gonna come out numbers. So for every 5 seconds, this produces output, which says log and then numbers here. It's gonna print out the temperature, comma, pH value, comma, and water level. This format is very useful because it's very readable because it's separated by commas, and you can easily distinguish which is which. And the data from the serial monitor can be copied into Excel or a graphic tool. And it also helps confirm whether sensors or relays are working properly.